Welcome everyone to this week's Biome seminar. In case you haven't heard this before, Biomes is YSE's flagship forum for bringing cutting-edge research and impactful work to the YSE community. In this vein, we are super excited about today's Biomes, which is hopefully the first of an annual event that I will lovingly call Postdoc Day. This is really a chance for us to show off some of the amazing work that is being done here at YSE by our postdoctoral researchers. So joining us this week and helping us kick off this tradition are Samuel Shaheen, Elisa Tedaldi, and Garam Byun. They're coming from Jim Sayers' hydrology research group, Professor Michelle Bell's lab, and the Yale program on climate change communication. Each of these postdocs has 10 minutes to give their presentation, followed by a panel discussion with the four of us up here. So with that, help me welcome our first speaker to the stage.
Perfect. Hello, everyone. Thank you all for being here today, and I'd also like to thank the BIOMES committee for this wonderful opportunity to share my work here. Again, my name is Garam. I'm from Professor Michelle Bell's lab. My research background is environmental epidemiology, and I'm particularly interested in how environmental exposures like air pollution or temperature affect our population health. And today I'll be talking about the link between those environmental exposures and dementia, which is a growing issue in the context of climate change and aging population. So let's start with the basic. What is dementia? So dementia is not a single disease, but rather a general term for their symptoms, including loss of memory, like language or other thinking abilities that interfere with daily activities. So there are different types of dementia, and the Alzheimer's disease is the most common type of dementia. So dementia is becoming a public health priority due to its significant burden, not only for those living with dementia, but also for their caregivers. So according to WHO, it's the 7th leading cause of death worldwide, and it cost $1.3 trillion in 2019. So currently, more than 50 million people are living with dementia, and this number is projected to almost triple by 2050. So aging is, of course, the strongest risk factor to dementia, but dementia is not just a normal part of aging, and many other factors can contribute, including like genetics, lifestyles, and even socioeconomic conditions. And recently, environmental hazards like air pollution or temperature also have been identified as potential risk factors for dementia. Well, the evidence is still limited, but the growing number of epidemiological studies are suggesting that high air pollution or like non-optimal temperatures may be linked to dementia. And several biological mechanisms also have been proposed to explain this connection. For example, like little particles like PM 2.5 can get into our bloodstream and even reach to the brain, causing oxidative stress or inflammation, like damaging brain cells. And heat exposures also can lead to like poor blood circulation or like imbalances in our brain chemicals, all of which could speed up cognitive decline and increase the risk of dementia. But there still remains a research gap, especially when it comes to people already living with dementia. You know, dementia is not like the flu. It's a chronic condition. So once it develops, people have to live with that for years. And compared to general other older population, people with dementia are more likely to have additional health challenges that make them even more vulnerable to environmental stressors. So for example, they often have impaired thermoregulation, which means that they have trouble regulating their body temperature, and communication barrier or social isolation, making it more difficult for them to recognize or respond to environmental dangers. And they also are more likely to have multiple other health conditions like cardiovascular diseases or other mental health problems. However, research on how these environmental exposures affect the various health outcomes in people living with dementia is still very limited. So to address this research gap, I conducted a study in South Korea, where they have one of the fastest aging population in the world, and I'm from South Korea. So the goal of this study was to examine the effects of short-term ambient temperature exposure effects on hospital admissions and mortality in both people with and without dementia. For this, we obtained the data from Korean National Health Insurance Service. We identified individuals as having or not having dementia. And then we tracked their hospital admissions and death records to evaluate whether these outcomes are associated with daily temperature exposures. And here are the main preliminary findings. So x-axis here in this graph is temperature, and y-axis is the risk of hospital admissions specifically for dementia. And this graph is saying that the risk of hospital admissions for dementia increased at very extremely high temperatures. And this graph showing the relationship between temperature and hospital admissions and mortality for all causes, not only for dementia. And we found that extremely high and low temperature increased these outcomes. And the risk was more pronounced in people with dementia, shown in orange color here, than those without dementia. So these results suggest that people with dementia may be more vulnerable to extreme temperatures compared to those without dementia. The next study I would like to share is about PM2.5 and hospital readmissions in the US. So some previous studies have looked at the first hospital admissions for dementia, but not much is known for hospital readmissions in people already living with dementia. So hospital readmission is a patient being readmitted to the hospital after a short time, within a short time after discharge, like usually within 30 days. So these are major healthcare issues because they raise this medical cost and also put extra burden on the patient and their caregivers. So our research question was to examine whether the short-term exposure to PM2.5 increases the risk of hospital readmissions in people with dementia. So we obtained hospital admission data from Medicare beneficiaries. We first identified individuals hospitalized with dementia, and then tracked their all subsequent admissions. And we defined readmissions as those occurred within 30 or 90 days after discharge. And then we examined whether PM2.5 exposure is associated with those readmissions. Our preliminary analysis found that higher PM2.5 exposure increased the risk of both 30 and 90-day readmissions. So these findings suggest that some readmissions in dementia patients may be preventable by reducing air pollution. All right, so stepping back to the context, we're living in an era of climate change and population aging. So climate change is driving more frequent, severe weather conditions and extreme temperatures, and also worsening air pollution, like through droughts or wildfires. And many countries are experiencing rapid population aging. So this means that while environmental hazards are intensifying, our population is becoming more vulnerable. And based on what we've discussed today, it's clear that the health burden of people with dementia lies at the intersection of these two growing challenges. And that is why I think more targeted policies or strategies will be needed to protect the health of people living with dementia in the future. Right, that's it. I would like to thank my advisor, Professor Bell, and all the collaborators who have supported me on this project. Thank you for your attention.
Can everyone hear me okay? Perfect. Well, thank you for the opportunity to present today. I'm Sam. The title of my talk is What Do Watersheds Teach Us About Carbon Capture? So one thing I think is cool about all our talks today is that climate change is the thread linking all of them together, even with our very different questions and approaches. And as my title maybe hints, I'm focused on the question of whether we can actually pull carbon out of the atmosphere. So one thing I want to highlight is that current IPCC assessments tell us that in order to limit warming by the end of the century, to meet the targets in the Paris Climate Accords, we need to develop negative emission technologies to pull carbon dioxide or CO2 out of the atmosphere. There's a number of different pathways or potential technologies we could use to accomplish this. I'm going to be focused on what's called enhanced mineralization on this schematic, but I'll be referring to as enhanced rock weathering. So compared to some of the other pathways like pulling CO2 directly out of the atmosphere or say reforestation, rocks might seem a little unintuitive as a method to pull carbon out of the air. But my PhD is in geology, and to a geologist, this makes perfect sense. The reason for this is that on geologic timescales, much longer than the time span over which we as humans have been really messing with the atmosphere, the weathering of silicate minerals helps control the concentration of CO2 in the atmosphere and keep the Earth habitable. The reason for this is that when you have a silicate mineral like wollastonite, calcium, silica, oxygen in that structure, it can react with CO2 dissolved in water in a process that we call chemical weathering. So this produces cations like calcium, as well as converting carbon dioxide into bicarbonate. And so these can eventually be transported to the ocean where they're sequestered on very long time scales, especially if they precipitate out as secondary minerals like calcium carbonate. So this is great for long-term habitability of the Earth. At the present, we have an order of magnitude problem, right? Which is that the weathering yearly, the amount of carbon dioxide we're pulling down from all the rocks on Earth is over an order of magnitude lower than the rate at which we're increasing carbon in the atmosphere. So the goal of enhanced rock weathering is can we speed this process up, right, to match the rates at which we're pumping carbon into the atmosphere? And so we can accomplish this potentially by taking really silicate-rich rock, like basalt, grinding it up to increase the reactive surface area, and then spreading it on the land surface on, say, crop fields or forests. So integrated assessments do suggest that if we pursue this at a very large scale, that we could potentially offset gigaton scale quantities of carbon dioxide, which is a sizable chunk of what we need at a competitive cost. And there's reason to think this isn't totally pie in the sky. We already apply really large amounts of rock to farm fields in the US annually in the form of liming, where we spread limestone to offset soil acidification. And so enhanced rock weathering offers you similar co-benefits while also contributing to offsetting ocean acidification and potentially increasing nutrients and crop yields in soil. So that all sounds great. What's the catch? Well, like a lot of processes in our carbon cycle, actually understanding how efficient enhanced rock weathering could be, which is critical if we're going to pursue this at scale, and especially if we're going to do so using carbon credits, is influenced by a large number of key processes that happen at different scales and parts of the Earth system. So a lot of research is being done on this question. Researchers over at EPS have developed methods to get the sort of precision we need to understand mineral dissolution in soils. And we can pair these up with soil models to really connect that weathering of mineral to carbon sequestration. Over in the stream side, there's been promising work suggesting that CO2 off-gassing from streams is not going to be a major source. So not more than 5% of the carbon we're sequestering is likely to off-gas in most cases. What we're really missing in understanding, but what's key to the timescales of enhanced rock weathering is the transport from soil to streams in watersheds. And so the focus of my talk today is going to be talking about understanding and identifying the key watershed processes that influence this export of products. So watersheds are also really cool because we can use relatively simple measurements to understand a lot about what's happening across a whole watershed. So hydrologists have long taken advantage of the fact that if you can construct a water budget, right, measure your inputs in precipitation, your outputs through discharge from a stream and evaporation and transpiration, you can begin to understand a lot about how water moves through a watershed, whether it's moving on the surface or in shallow subsurface or deeper groundwater pathways. And this is all really important to the chemistry too. So how fast that mineral dissolves, how quickly these products like bicarbonate will move out of the watershed, whether they're retained on the soil, travel in the stream, et cetera, is all really interlinked. And so the idea of watersheds as sort of a big reactor is nothing new in geochemistry, but what is new is our ability to really model this at scale. So I've been working with a model called ATS, the Advanced Terrestrial Simulator. It's an integrated hydrology model, so we can look at subsurface and surface flow of water, but also look at chemistry at the same time, so the chemical reactions happening as that water moves. The other challenge with enhanced rock weathering is that a lot of the studies on it are pretty new. So there's not a lot of field studies period, let alone watershed scale studies or at the time spans we would want. So I've been taking advantage of a sort of accidental ERW experiment at the Hubbard Brook Experimental Forest in New Hampshire. So Hubbard Brook got hit hard with acid rain. The soil was really acidified and the forest health was struggling. So 25 years ago, they spread wollastonite across an experimental watershed at Hubbard Brook. And today we now have a 25-year record of the stream responses to this application of silicate mineral. And so there's a lot we can learn here, right? The soil is really acidic. And so you see a more muted response in bicarbonate concentrations in the stream, in part because it was so acid loaded. But we see a big response in calcium and pH. And even though calcium concentrations remain pretty elevated compared to the reference watershed, only a pretty small portion, about a third of the calcium applied on a mass basis as mineral, has actually left the watershed. And so there's still a lot lingering, and we want to figure out where. So we started by looking at the hill slope scale. So taking a two-dimension simulation, carrying over key hydrologic and geochemical characteristics of the watershed. What I'm showing here is calcium concentrations across the watershed, and you can see shortly after we apply wollastonite, you're having high concentrations in sort of the shallowest soils here, which makes sense since we applied it at the surface. But even over multiple years, it's really these shallow flow paths that are key here. They're really carrying the products. There's not a lot in the deeper groundwater. If we move it into 3D, then we can really start to compare our hydrology to what was actually observed in the field, make sure we're getting that right, and we can understand the real spatial distribution of these processes. So for example, if we look at pH and calcium in the baseline simulations without any mineral spread, we're seeing higher pHs and calcium concentrations really following the stream channel. And this makes sense since that's where you tend to have groundwater upwelling. Now, if we look at it post-application, and this is showing sort of the shallowest groundwater, so the soil pore water in the watershed, we've really flipped that on its head. So you have a lot of high pH, concentrated waters that are sort of lingering in the soil, waiting to be flushed out. This is still very much a work in progress, but hopefully I've shown you some of what we can do with these models and hopefully can make more progress on as we continue to calibrate our model and build processes in. And hopefully I've emphasized how cool watersheds can be at understanding how ERW works and could pull CO2 out of the atmosphere. So I'd like to thank all the following, and I'm happy to take questions on this during our Q&A period. Thank you.
Hi, everyone. My name is Elisa. I'm a postdoc at the Yale Program on Climate Change Communication. And today I'm going to present to you the first project that I've done during my postdoc, Climate Change Communication. Is it a matter of what we say or how we say it? So I think that we can all agree that each of us communicate differently. And especially when we talk about climate change, which I guess it's something kind of common for people in this room, we can explain facts or share our opinions very differently, depending on who we are talking to and what our goal is. And if we look at the real world, we have some examples of people trying to really put a lot of emotions in what they're trying to communicate to make clear what an emergency we're living in and the fact that we need to take action now. So is this strategy effective? What does the science tell us? Okay, So if we look about the literature on communication in general, a well-known effect is the framing effect, for which like we know that people make decisions and judge like different situations, evaluate them differently depending on what kind of information we present them. And this is also true when we talk about climate change. So for example, if we have studies like comparing when we share positive or negative aspects of an issue and how people perceive them, or if we share like some information about the environmental impacts compared to the economical impacts, people like change their perception of the issue itself. And what about emotions? So we know in general that emotions influence our own decisions. And this is also true for like climate change communication. And when we look at studies where where researchers study like how the recipients were like perceiving themselves and what kind of emotional state they were in, even before being exposed to a message, that influenced how they perceive the message that we study for months and try to manipulate for like the best, most effective communication. And the same goes with like the tone of the message that can change how that is received like on the other side. So it seems pretty clear that emotions play a role, but nowadays it's still missing what is the difference between what we are saying and how we are saying it. So what of these like two components should we like take care of, and like where the emotionality of the content, so the kind of words that we decide like to put like in our speech, or how we say like how we like deliver the message to the people. So here comes our study. To give you like a brief like background on how like studying psychology and communication is done like most of the times probably. We collected data online. So we sent like an online survey like through a platform. Participants just access it. They are informed about like the study itself. And then we measured some variables. In this case, we measured them both before and after the treatment. And for the treatment part, basically each participant was randomly assigned to one of the 7 conditions that I will just explain in the next slide. And in the end, yeah, we also collect some social demographic information and other things. So for this study, we collected almost 3,500 participants. So participants were randomly assigned to one of these 7 like audio clips that they were asked to listen to. So there was a control audio clip about like something completely unrelated. So it was some information about cheetahs in this case. Or they could have been assigned to one of the 6 treatments, which varied on the tone, could have been like emotional or neutral, or the content, which could have been like emotional, semi-emotional, or neutral. So for this study, we hired like an actor, and we asked them like to read the context that we created, where we vary like the words, if they were like very, very emotional, a little bit emotional, or just like as neutral as possible that we could think of, and to read it like with an emotional or neutral tone. And oh yeah, and basically the context in all these 6 treatments was explaining the link between climate change and extreme weather. So as I said, we measured some variables both before and after the study. Specifically, we asked participants to report their belief that climate change is negatively impacting extreme weather events. We asked them to report their level of worry about extreme weather and climate change, and their support for government action. Only after the treatment, we asked also their willingness to share the audio clip with other people as a more kind of behavioral like variable. We also asked some other information, but we don't have the time to talk about that today. So if you have any question about that, we can talk about it later. So for the research question that we had, is really about like how the emotionality of the tone and the content can affect the communication about the link between climate change and extreme weather. And we consider like all the different outcomes. You don't see all of them here, but I just explained them. So looking at the results, so compared to the control condition, which was like not related to climate change, what we can see is that all the treatments had a positive effect on the belief that climate change is negatively impacting extreme weather events. This means that all the participants exposed to one of our audio clips, where we manipulated the emotionality of content and tone, they all had reported a higher belief that climate change is negatively impacting extreme weather events compared to the control condition. But as you can see, there is no difference between the treatments. Looking at the worry about extreme weather on the left and climate change on the right, we find similar results. So compared to the control condition, all the audio clips had a positive effect, but one here on the very far right, which that was not different from the control. For the support for government action, we again find similar results. So all the treatments except the semi-emotional content neutrally delivered were more effective in increasing the support for government action in participants compared to the control condition. And finally, looking at our more behavioral measure, the willingness to share the audio clip. In this case, we didn't consider the control condition because it was just really related to something else. And here we compared all the treatments to the most neutral that we had, which was the neutral content neutrally delivered. And as you can see in this case, we find that the neutral content emotionally delivered was the only one that had a higher, the people in that condition were more likely to be willing to share the audio clip compared to all the other conditions. So just to discuss a little bit, every treatment had a positive effect on the outcomes compared to the control, but this effect is not different from each other. We know that future studies are needed because this is the first study trying to really separate the two emotionality components. And we know that we were focused really on a specific topic that could be already emotionally charged for people, or there could be many other reasons why we couldn't really find a difference between these two emotionality dimensions, or it could be just that it's just more important to talk about it. And so this is actually really a conclusion that it seems that communicating information for this specific topic, at least, is effective no matter how you say you deliver your informations. And so my suggestion would be just to keep talking about climate change with people. Last but not least, here is the amazing team that helped me with the project and supported me and get me actually involved in this. And I think that's it for today. Thank you for the attention.
All right, yeah, so we're going to turn this to a Q&A now. If anyone has super hot and pressing questions you would like to ask our postdocs, please do while we get settled up here. If not, I have some fun questions for them. But first, we'll open up to you guys if anyone has any questions. Okay. Oh, yeah.
On the question of hospitalization of people with Alzheimer's, I have a following question. I presume that an awful lot of people with Alzheimer's do not take themselves to the hospital. And I'm wondering if it's worth looking at the caregivers. That is, they may be monitoring temperature or their own personal feelings from the particulates better than the Alzheimer's or the dementia affected people.
I'm really sorry. Can you please repeat the question again?
Yeah. I'm wondering about for the caregivers.
Oh, the caregivers.
I'm hypothesizing that the Alzheimer's patients don't take themselves to the hospital. They're taken either from a home that they're living in with family, or they're taken from a care facility. And so I'm wondering if it's worth looking at the effects of the environment on the caregivers, not just the Alzheimer's people.
Yeah, that's a really, really good question. Absolutely, that's worth to looking at. But for my study, I only had data for those with Alzheimer's disease or related dementia. But thank you for great comments, and that was very interesting.
We have a question up front.
Just a similar sort of follow-up question actually to that, also on the Alzheimer's research. You said that we know quite a bit about the first-time admissions. Could you just speak really briefly to what trends that we see with first-time admissions in Alzheimer's related to climate change?
So actually, it's hard to say that the first hospital admissions for dementia or Alzheimer's disease means that that is onset of disease or Alzheimer's disease. But we can, those studies usually, looking at people have no history of previous Alzheimer's disease or dementia, and then find if environmental exposures is associated with the increased risk of first hospital admissions in people, just in general population. So what's the difference between those studies and the present study is that I've looked at the hospital readmissions in people already living with dementia specifically. Is that?
You have a question over there?
Hi, for Elisa, the intake group, what was their likelihood to believe that climate change is real and that it has an effect on their life in general? Beforehand, do you think that your results would have changed if they were, at a 5% that they believe it compared to they're already at a 50 or they're a YSE student?
That's a very interesting question. So we measured that as pre-treatment, and we already know that most of the sample was already believing that climate change is happening and is impacting extreme weather. We did also some analysis trying to see if the changes, their perception after the treatment, based on their previous knowledge, let's say, and belief, but it didn't change that much. There was not such a moderation or anything. The results were pretty similar. It could be though that most of the participants already believe that climate change is impacting extreme weather. So that's definitely an important question to work on. Thank you.
Hi, I want to thank all three of you for these great presentations. I don't want to be holding my pizza. I also have a question about the climate change communication study. So if I understood you correctly, the people knew they were signing up for a climate change study when they signed up. Is that correct?
No, they didn't know that.
They
knew that they were exposed to, with the informed consent, that they were exposed to an audio, and they were asked questions.
Oh, okay. So because I was going to ask about selection bias, you said that most people on the study believed climate change is real. So do you think there are any selection bias issues of people who are opposed to science, not just climate change, but science denialism, are just not going to participate in your study? And so
Well,
so those people are not in the pool of people, and those are the people we really need to affect the most. Thank you.
Yeah, that's an interesting point. So we collected the data through a platform which is called Prolific. And I think there are also some studies really trying to understand what kind of sample we have there. So there is this giant pool, and we can try to just collect data for there. But of course, people signed up there. So I guess that there is a little bit of bias of people who are willing to participate in studies and being exposed to these as many other different surveys. So there might be that, definitely.
This one's for Sam. You said that one of the co-benefits of weathering is having the carbonate run off into oceans and combating ocean acidification. So do you think that putting those treatments closer to coastal areas will be more effective for carbon capture, or are there still benefits of putting it out elsewhere, like the Midwest, and having that still run off? And are there transport processes available to continue that runoff down to the oceans?
That's a good question. Yeah. Once it's in a stream, it should move pretty quickly to the ocean. The speed at which groundwater moves compared to, say, the Mississippi River can be sometimes substantially slower. And so in some ways, maybe the key control is how quickly it makes it into a stream, less than sort of proximity to coastal areas matters, but then all of that is climate controlled as well. And so more humid areas, say, are better for generating a lot of bicarbonate than a really arid area. And so I think you absolutely can find geographic areas where it makes a lot of sense. I think directly trying to put it near the ocean maybe isn't the most important, because I think you could still get ocean benefits if you're generating a lot in the Midwest, as long as it can quickly move into a stream.
All right. Well, you guys were very on time with your presentations, so we have lots of time for other questions. Given that you are in your postdoc careers, as you're looking forward, either through your career or the future in your field, is there one part or one aspect of your fields that excites you the most, or what you're looking forward to asking or working on during your careers? Whoever wants to start,
Personally, so I come from like a psychology background, and I would say that being in the environment domain, what is really like interesting to me is how it can be like multidisciplinary. And I did my PhD in Italy, where it's not really a thing to do a lot of like multidisciplinary things, but it's way more here, for example, like in my lab as well. And I think that is very interesting, because you can combine different backgrounds, different knowledges, and like put them really together to create something bigger and possibly like more impactful. So I would say probably that part for me.
I think so. I come from a geology background, like I mentioned. I think the multidisciplinary aspects of the future also are exciting to me. I think maybe what's exciting and scary is there's also a lot of recognition that sort of these fundamental processes are really being shifted by humans, and a lot of research still to do to understand how some of these sort of natural earth systems are changing. And so it makes a lot to study. It's maybe not uplifting, but definitely.
So in my case, my background is epidemiology. And the one point that attracted me in epidemiology is that it provides quite basic but very essential and direct evidence to public health policies. So during my research, I sometimes have opportunity to see that my research being actually used in policymaking process, and that's really rewarding. So that is one part that making me excited and rewarding what I'm doing right now.
Awesome. If anyone thinks of questions as I'm going through mine, please feel free to raise your hand. This is supposed to be a conversation, so.
I'm going to take that opportunity to ask a very general question. I'm assuming we have a lot of PhD students today. Yes, many, several. Is everybody else a postdoc? Then I want to say, okay. I was just wondering, just for people who are PhDs in the audience, if you could give some thought into how you went about finding your postdoc position, because there are lots of different paths to how to find a postdoc, and maybe any advice you would have for people who are looking for a postdoc.
Okay, so thank you, Michelle. She's my advisor. So I did my PhD in South Korea, and actually this lab, Michelle's lab, was the only lab that I wanted to pursue my postdoc. So I was kind of very lucky to find this great lab that I can work on. So I don't know how to say, but I think it's really lucky to have find somewhere your research interest is well matched with your postdoc lab, and that is really important to find where you can whether you can extend your research field, or if you want to change your research field. I think it's really important when you find your lab to continue your postdoc.
Yeah, I guess so. Like in my field, more the physical sciences, and this might be true for everyone here, but there's sort of postdocs that are fellowships, postdocs that are grant money someone has, And there's, say, you can apply to a posted job, or sometimes you just cold email someone. And I think I kind of like applied across the spectrum. Like you can find success in any one of those pathways. I think connections help too, because like I had met Jim during my PhD, was familiar with his work and like knew kind of who he was, what he was working on, that he was a nice person, just always intimidating. um, and like I guess my PhD was kind of in the heart of COVID, but so it was hard to make connections. But it's useful to kind of get to know your peers and who they're doing their PhDs with, and get to know other scientists in your field, because then you have a sort of a sense of what direction you might want to go, who you might want to work with.
Yeah. I think that so I did my PhD in Italy, and I spent a year abroad in Boston. So that's where like I had my first experience here in the US. And it really helped me like to talk with people, like to ask them like, oh, how should I like look for like a postdoc, and really like practically like where should I look for also for the advertisements and these kind of things. And besides that, I think that by the end of the PhD especially, you develop kind of like a clearer idea of what are your interests, what you want to like keep doing research on. So I would suggest probably like to start from there, even being like a little bit more selective. Maybe you won't find like a position because at that time it's just maybe a difficult time for grants. But still like it makes sense to try that first, and then like try other options and like broaden a little bit like your interest or whatever, but still like trying first to go for what is your real like first goal, and trying to achieve that as you can. Yeah.
Awesome. Did I see a question up front?
Thank you for the presentation. I was curious about the dementia study, and particularly if you could talk to us a little bit more about the measurement component. So what spatial extent did you measure PM 2.5? Because I presume whether you measure it outside in the neighborhood or activity spaces, I mean, just intuitively, I would think that people living with dementia spend most of their time indoors. And so how do we think about that?
Yeah, that's a really great question. And I didn't have much time to explain about my exposure measurements. So I mostly used measurement for the temperature analysis. I used monitoring data like outdoor temperature. So for that. So I used outdoor monitoring data for temperature, and for PM 2.5, I used modeling data for outdoor PM 2.5 exposure. So I linked the data of health data with outdoor temperature or PM 2.5 data to see the link between outdoor exposures and hospital admissions or mortality. But as you mentioned, that is really important that people with dementia may have reduced mobility, or they mostly spend indoors. But I think it's important to say that we still find those associations, even though they are mostly staying indoors. So I think that's really interesting findings in this study.
Awesome. Okay. Well, we can keep going. So, oh, did I miss one? No, please.
For the dementia study as well, do you think that extreme heat or extreme cold physiologically will have a greater impact on dementia and hospital visits in the future?
Yeah, so my hypothesis was that extreme heat or extreme cold temperature will affect not only for increasing risk of developing dementia, but also for like other health conditions, like other mental health problems or like cardiovascular problems in people living with dementia. So temperature or air pollution exposure not only affect dementia-related issues, but they are very big risk factors for various health outcomes that I mentioned, just say like cardiovascular, respiratory, like mental health problem, things like this. So they are, I just wanted to say that those exposures are also a big risk factor for overall health outcomes in people living with dementia. Is that?
Okay, I don't want to miss anyone again. Okay. Let's have maybe a fun one for our last question. If you weren't in research and you could do anything else in the world, what do you think you'd be doing instead?
Sorry.
Do not let reality constrain you. Tim, do you want to start?
I think this is the one I told you. It's a really
Oh,
hard
no.
question.
Oh,
of
okay.
you.
Not that one. Okay.
No, you can do it.
Because like if it were me, I would definitely be like trying to explore Mars. I think that would be my answer. It's still, yeah. Exploring.
That's a scale I hadn't thought of here. Well, I don't know. I think I had a debate with someone this summer who was married to a PhD student, but not a PhD student, who was grilling PhD students. Like, would you still be doing this if money and everything was no object? Like,
Right.
if you were retired, would you still want to do this for fun? And I kind of think, yeah, but
Right. Yeah.
like I
don't-
like sampling streams and understanding what's going on there. But
Do you do a PhD if you're not in it for the love of the game? Probably not is the answer. Does anyone have any wild ideas?
Oh, it's still like doing kind of the same things, honestly, like more maybe like in the field.
Okay.
So like applying the research that I'm doing now, but yeah, sorry. I know
Okay.
that it's not the response we're looking for.
We have life satisfaction up here on the stage. That's what matters. That we've made right decisions. Well, so then since this is what you would want to do, like resiliency is probably a big part of research. Things will go wrong, experiments will fail, data won't come through when you need it to. So, when research gets frustrating or difficult, is there something that like keeps you going or some part of doing research that keeps you engaged even when the going gets tough?
Okay, so actually, I don't think there is such a thing that like easy research. Research is always difficult, always frustrating, always come across results that never expected. So actually, I think, struggle with challenges is the fundamental part of research, and that makes what you keep moving forward. So I don't think research has to be difficult and frustrating always for me.
Okay.
I would echo that. I think like having people around you helps too, like the collaborative aspects. You have office mates you can go vent to and something goes really wrong. I think that really helps compared to like stewing in it by yourself, which is easy to do. I think surrounding yourself with people, like the collaborative aspects are some of the perks, I think, too.
Yeah, I feel that together with the social support, that's totally like something important to me is to, it's probably like during the PhD, it was running, now it's becoming like doing CrossFit, like really having something else to really like get it out. And then we know, okay, now I have like a clear mindset, I can get back to it, I will do it, I get it. And just trying to also reset outside of like the research in a sense that helped me.
Okay, I think that's all the time we have. So round of applause for our participants. All right, well, thank you all for coming. Thank you all for participating, and we'll see most of you next week.